Welcome to example 1 on ellipses. I'm going to give you an equation of an ellipse in standard form, and you have to identify and graph the center, the vertices, the foci, and the eccentricity of this particular ellipse. All right, so when I go to analyze this, I notice that if I look back from Proofville, that if I'm looking at this, I don't have any minus h's or minus k's going on. So this is what's happening. I have a center of the ellipse at 0, 0 because if I look at my equation right up here, I don't have any x minus h's going on or y minus k's going on. So the center of my ellipse is at 0, 0. Next thing that I want to notice, I see that 64 is the bigger number underneath the x squared. I can think of this as 8 squared. 28, the square root of 28 is equal to 2 root 7. So that's 2 root 7 squared. So my major axis is going to be the x values, or a horizontal major axis, because the larger of the two numbers, 64, is underneath the x squared. So if I want to make a quick sketch so far of what I have, I know that if I go from the center 0, 0, and I go 8 units to the right, and I go 8 units to the other side of the center, what I just graphed right here is my major axis. So since this is my major axis, I know that my vertices fall at 8, 0 and at negative 8, 0. Okay. Now, 2 root 7, if I think of root 28 is in between root 36 and root 25. So that means root 28 is somewhere between 5 and 6. So I'm going to go up 1, 2, 3, 4, 5, and a little bit more. And down 1, 2, 3, 4, 5, and a little bit more. Let me move this up a little bit. Okay. And so here is a really, ooh, I missed, but you get the picture. Here's a really rough sketch of my ellipse. Now I need to figure out where the foci belong and the eccentricity. Let's talk about the foci. We need to go back to Proofville and remember this sheet. Remember how we talked about that we could talk about that b squared equals a squared minus c squared, or that c squared equals a squared minus b squared? Remember what c was. C was the distance from the center to a foci. So we are going to use this c squared equals a squared minus b squared, where a represents the distance from the center to a vertice, and b represents the semi-minor axis. So going back to our problem, in order to find the foci, I need to use c squared is equal to a squared minus b squared. So I'm trying to find c squared. I'm trying to find c, which is where my focus points are going to be. That's what I'm trying to, I don't know that this is where the spot is, but that's what I'm trying to find, are those focus points. My a squared in this case is going to be 8, okay, because that is the distance of the center to a vertex. And then I need to subtract off the distance squared of my minor axis, which is 2 root 7 squared. Well, if you notice, what you end up doing, c squared is going to be the difference of your denominators and then its square root. So c squared is equal to 36. So c is equal to 6. Technically, there's a plus or minus when you take a square root, but we're dealing in distance. So if I go 1, 2, 3, 4, 5, 6, okay, this is one of my foci, and if I go 1, 2, 3, 4, 5, 6 the other direction, there's my other foci. So the coordinates are 6, 0, and negative 6, 0. And last but not least, eccentricity was discussed in your Inspire lab. It was problem number 5. Okay. And basically it measures ovalness. And it told you that if we use the cursive E, not to be confused with the Euler number E, that it is a ratio Okay, not a ration. It is a ratio of the distance of your foci over the distance of your vertex. So in this case, our ratio, our C value is 6. Our vertice is 8. So our eccentricity is 3/4. And so I have my center of 0, 0, vertices at 8, 0, negative 8, 0. I have my foci at 6, 0, negative 6, 0. And I have eccentricity of 3/4. And then I have my pitiful excuse, yet it works, sketch of an ellipse. And here we are at example 2. The difference between example 1 and 2 is going to be where the center is located. So here we're going to find still the center, the vertices, the foci, the eccentricity. We're going to sketch. And here is my equation in standard form. Because I see these parentheses, my center is no longer at 0, 0, but I take the opposite. So my center is going to be at negative 3, positive 2. So let's go ahead and plot that. 1, 2, 3, 1, 2. This is my center. Okay, now, if I notice my denominators, 16 is bigger and it's underneath the y. I can think of this as 4 squared. So this means my major axis is going to be vertical. So if I take my center and if I go a distance of 1, 2, 3, 4 above, and then go a distance of 1, 2, 3, 4 below, okay, this is my major axis that I've just made. Then if I think of 12, the square root of 12 is going to be 2 root 3, okay? And the square root of 12 falls between the square root of 9 and the square root of 16. So this is a number between 3 and 4. I'm going to go a distance of 1, 2, 3, and a little bit on one side, and 1, 2, 3, and a little bit on the other. And now I have a quick graph of my ellipse. So my vertices in this case are going to be this point. So I have negative 3, and then I have 1, 2, 3, 4, 5, 6. Negative 3, 6 is one of my vertices, and this is the location of my other vertice. So that is also at negative 3, but I go down 1, 2, 3, 4 spaces down to negative 2. Okay. My foci is still c squared equals a squared minus b squared, and a squared represents my major axis. So in other words, you should never get a negative when you're doing this. So basically you take the square root of the differences of your denominators. Okay, so c is equal to 2. So that means I have to go a distance of 2 for one of my foci points and down 2 for my other. So this focal point, or one of the foci points, is going to be at negative 3, 0. And then the other one right here, this coordinate, is at negative 3, 1, 2, 3, 4. My eccentricity is a ratio of the distance of your foci over the distance of your vertice. So in this case, the distance of each of my foci is 2 units, and the distance from the center to a vertex is 4. So the eccentricity, or the measure of overness, is 1/2. All right, for example 3, we're still going to be finding similar information, the center, the vertices, the foci, and eccentricity, but I gave you a complicated version of the equation. It's not so nice. It's not just handed to you in standard form, and you're going to have to do a little work to get it there. So I have x squared plus 4y squared minus 6x plus 20y minus 2 equals 0. Completing the square is going to come back to haunt you. We're actually going to have to do it twice. So here's what I'm going to do. I'm going to reorder my terms, and I'm going to bring the constant to the other side. So I'm going to group all of the x's together. So I rewrote the x squared and the minus 6x. Okay, I'm going to leave a little bit of a space. Then I'm going to write the 4y squared plus the 20y. Again, kind of putting things in the y family together. And then I'm going to bump the negative 2 to the other side. All right, let's just deal with the x family. If I complete the square, this is pretty easy to do. I can take negative 6 divided by 2 and square it, which is negative 3 squared, which is 9. But if I'm adding 9 to one side of the equation, I have to add 9 to the other. So this portion right here is going to factor into the binomial squared, x minus 3, the quantity squared, and I have 11 on the other side. But we have to have a little discussion about the y family. I cannot complete the square because I have a coefficient other than 1 on the y squared. Furthermore, my goal is to get this to be a binomial squared, and I don't want to divide everything through by 4. I'm going to get crummy fractions, and life is just going to be very complicated. But what I'm going to do here is I'm going to factor. So kind of watch along, because it's kind of slick. It's not that hard to avoid fractions. If I factor out a 4, I'm left with y squared plus 5y. So again, see if this makes sense. If I take 4y squared, I get this term back. If I take 4 times 5y, I get 20y back. So now I'm going to complete the square with the 5. I have to take 5 divided by 2 and square it, which is 25/4. But what you're really adding is not 25/4 to this entire side of the equation. What you really added was 4 times 25/4, which is just 25. So again, to repeat, when I completed the square with just this part, I added 25/4 inside the parentheses. But remember, I had factored out a 4. So if I would redistribute this back, I would get 4y squared times, or plus 20y, plus 25. So what I actually have to add to the other side in order for this to stay equal is 25. So I end up with x minus 3, the quantity squared, plus 4 times y plus 5 halves the quantity squared when I factor that portion. And that's going to equal 36. But remember, when I do the equation of an ellipse, I need it to equal 1. So I'm going to divide everything through by 36. And now I finally have my equation in standard form, which is x minus 3 squared over 36 plus, that reduces, y plus 5 halves squared over 9 equals 1. So I know my center is going to be 3, negative 5 halves. So let's go ahead and plot that. Okay, so I'm going to go to positive 3, 1, 2, 3, and then negative 5 halves. Okay, so there's my center. Because the 36 is the greater of the two denominators and it is underneath the x, I know that I have a major horizontal axis. So I can think of this as 6 squared. So in order to get those vertices, I'm going to go 1, 2, 3, 4, 5, 6 units right, and then 1, 2, 3, 4, 5, 6 units left. So my vertices of this ellipse are going to be at 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 5 halves. And then my other one is going to be at negative 3, negative 5 halves. My minor axis is going to have a distance of 3. So if I count 1, 2, 3, and I just counted in the middle of the boxes, 1, 2, 3. There's my minor axis. So again, you know my ellipses are not the best drawn. Okay, there's my ellipse. In order to find my foci, I have to do c squared is equal to 36 minus 9, which is equal to 27, which is 3 root 3. Now I know that's not a nice number, so I basically have to go a distance of 3 root 3 on either side. So if you think of root 27 is in between root 25 and root 36. So this is 3 root 3 is a number between 5 and 6. So when I want to graph it, I would go 1, 2, 3, 4, 5, and just a little bit over. 1, 2, 3, 4, 5, and just a little bit over. And when I have to write that, this is not going to be a nice, neat number. It doesn't fall on a nice, neat corner point. So really what you had to do is I had to take the x value. Remember, my center here is at 3, negative 5 halves. This is at 3, and I had to add a distance of 3 root 3, and I had to subtract a distance of 3 root 3. So to get my foci, I have 3 plus 3 root 3, common negative 5 halves, and then I have 3 minus 3 root 3, negative 5 halves, and those are exact values of the foci. Lastly, to get my eccentricity, I want to take the value of the foci, which was a distance of 3 root 3, over the distance of a vertice or a vertex, which is 6, so the eccentricity is going to be root 3 over 2 when I reduce. And our last example 4, we're going to find the standard form of the equation at the ellipse with center at the origin, given the following information. We're given that the foci are at plus or minus 2 comma 0 with a major axis length of 6. So this tells me I know that I have x squared over something plus y squared over something equals 1. And basically you have to fill in the numbers that go underneath and we will have our standard form. So for those of you that need to picture what's going on, this is how I started the problem. I first of all need to determine, is my major axis horizontal or is my major axis vertical? Well, if my foci are located at 2, 0 and negative 2, 0, then this tells me that my major axis is horizontal and the bigger number needs to go under x squared. They then tell me that the major axis has a length of 6. So they didn't say semi-major axis, they said the entire major axis. So that means a semi-axis or a semi-major axis would then be 3. So if 0 is my center, I would go out 1, 2, 3 for a vertice on either direction. So that means if I take the semi-axis 3 squared, I know so far I have x squared over 9 plus y squared over a number I need to fill in equals 1. So you can also think of this as this was of the form a squared, a was my major axis, and I need to fill in the b squared underneath the y squared. All right, well, I know that in order to find the foci, I can use the formula c squared equals a squared minus b squared. Well, I know that the distance from the center to a foci is 2. I know that the a value from the center to a vertice is 3. So that means 4 is equal to 9 minus b squared. So negative 5 is equal to negative b squared. So b squared is equal to 5, and b squared is the number that goes in here. Therefore, x squared over 9 plus y squared over 5 equals 1. And even though the directions didn't ask you to sketch, if I wanted to finish this sketch, the square root of 5 is a number between the square root of 4 and the square root of 9. So it's a number between 2 and 3. So I'm going to go up 2 and a little bit more, down 2 and a little bit more. And if I connect all of those points, I would get my, again, crazy excuse for an ellipse. So now you're ready to start the first part of, and actually kind of the main part of our assignment, which begins on page 646. And you can try numbers 1 through 29 odd. Good luck.